find a dead body. Library. Dead body. Library. Come now.
What do you got for me? I got one homicide for you. Murder victim was found an hour ago. Lacerations are side of the body right here. And here, there's signs of strangulation. And yeah, it's a great temperature.
Alright, take it again. Bring it back to the lab.
Video log 68. Female victim was identified Julia No. She's 17, 5'1", and Asian.
She was last seen walking around in the library, and she was found in the stairway next to the library. I found bruises on her neck, lacerations on the side of her body, and in addition, I found traces of skin under her fingernails, which are currently being tested.
And you got, you found the TOD?
What's the TOD?
Find me that?
No. Didn't know how to...
Come here, I'll show you. Alright, new guy. Remember how I had you get the temperature of the body?
Yeah.
Well, luckily for us, the victim was killed in a stairwell, which is kept at a constant temperature.
What's so special about that?
That lets us use Newton's law of cooling. Now, by plugging in the body temperature at a given time, surrounding environmental temperature, proportionality constant, and time, we can find the rate of change of the body temperature proportional to the body temperature minus the surrounding environmental temperature. Now, by integrating Newton's law and plugging in the evidence that we got off the scene, we arrive at the cooling model, which lets us find T, or time. To find the cooling model, we plug in the evidence that we got into the integral of the cooling law. Now we can start off by plugging in 70 for E because the stairwell was kept at a constant temperature. To find constant C, we plug in our first reading, so we plug in 92.4 for Y and 0 for T, which leaves us with 22.4 equals T. Now plugging this back into our original equation, and we get Y minus 70 equals 22.4 e to the kt. Now, we plug in our second reading into this equation to find k. So right here we get 91.6 minus 70 equals 22.4 e to the k times 1. Or simplified, we get 21.6 equals 22.4 e to the k. Divide 22.4 to both sides, and you get 21.6 divided by 22.4 equals e to the k. Now we ln both sides so that we can isolate variable k, and we get k equals negative 0.03636. Plugging this back into this equation, and we get our cooling model, which is y minus 70 equals 22.4 times e to the negative 0.03636. Plugging in the temperature of an average human's body into the cooling model should result in giving us T, or our PMI. So by plugging in 98.6 for y, we get 28.6 equals 22.4 e to the negative 0.03636 t. Divide both sides by 22.4, and you get 28.6 divided by 22.4 equals e to the negative 0.03636 t. ln both sides to get rid of e, and you're left with approximately 0.24434 equals negative 0.03636 t. Divide both sides by 0.03636 t, and you get t equals negative 6.72, or approximately 6 hours and 42 minutes before our initial time, 7 o'clock, which gives you TOD equals 12:16 p.m.
Video log 69. We concluded that the TOD was 12:16 p.m. We believe that this is the work of a serial killer because of similar cases we have reviewed the past few months. We have narrowed it down to one suspect, and his name is...